Hey guys, it's Coach Brian coming to you with the 1.5 notes. For these notes, we're going to be looking at the midpoint and the distance formula on a coordinate plane and actually be putting those to use. So these are pretty quick notes, and I'll go over them with you, talk about what the formulas are, and then do a couple of examples with you. And then the practice is going to be more of the same, using the formulas with some practical applications. So to start off with, you will need both of the formulas. The first is the distance formula. And so for the distance formula, we have the distance equals the square root of, let me see if I can make that a little thinner, square root of x2 minus x1 squared plus y2 minus y1 squared. So for this, we're actually going to get a numerical answer, just a single numerical answer, and that number will be the distance between the 2 points. So when you're looking at what does x2 mean, what does x1 mean, y2, y1, normally for these problems you're going to be given 2 points. Like for this, you've got all these points down here. So you could be given 2 points, and you need to decide which one is going to be number 1 and which one is going to be number 2. And it's kind of a personal preference. Sometimes it is easier math-wise to, treat one as number 2 and one as number 1, especially if you like to avoid working with negative numbers. But ultimately, the math should work out the same way. And so it doesn't really matter which one you pick as point 1 or point 2. When you're given those 2 points, you just need to stay consistent with them the whole time. Like point 2 needs to be point 2 the whole time that you're working that problem. Our other formula is our midpoint formula. And for the midpoint, we have midpoint equals, big set of parentheses, x2 plus x1 divided by 2, comma, y2 plus y1 over 2, close parentheses. So if you notice, this one, when you solve it, is going to give you an ordered pair. That means you're going to, when you get an answer, actually have an x and a y coordinate, and it'll be the point right in the middle of the 2 given points. So part of your practice for your notes is plotting these points, and I'm going to let you do that. Plotting points is not something new to you, so I'm going to, let you do that. I don't feel like I need to really cover that in depth on the notes. I will just add that when you are plotting your x, all right, your x-axis, this is positive, this is negative. When you're plotting your y-axis, this is positive, this is negative. So, moving on now, I'm going to work a couple of examples with you using both of these formulas. The first one I'll work is number 1. It says to find the midpoint. So you immediately know we're going to be using our midpoint formula. And it says between point B and E from these points above. And so just for the purposes of it, I'm going to say B is number 1 and E is number 2. So when I am putting x1 or x2, I'm talking about B being number 1, E being number 2. And then my actual formula is M equals, remember, big parentheses, x2 plus x1 over 2, comma, y2 plus y1 over 2, close parentheses. So B being my first point, okay, it has an x and a y. The -6 is the x, and the 0 is the y. And that's my first point. So I'm actually going to replace the x1 and the y1 with these values of -6 and 0. And point 2, which is E, has an x value of 0 and a y value of -8. And since it is my second point, I am going to plug those numbers in here. And when I'm adding these together, okay, I'm adding 0 and -6, and then I'm dividing by 2. So 0 plus a -6 is the same thing as subtracting 6. When you add a negative number, it's the same thing as subtracting. So it's actually -6, and then I'm going to divide that by 2, which is -3. And over here, I've got -8 plus nothing. So it's going to stay -8, and it will be divided by 2 and give me -4. Let me make that a different color so it's a little easier to see. -8 divided by 2 is -4. And so my final answer, my final ordered pair is -3, -4. So what that means is if I were to go up and graph these points, all right, B is -6, 0. So I'm going to make that point right there. And point E is 0, -8. So way down here. Okay, if I was to connect those two lines, let me do my best right here, just freehanding it. Not great, not perfect. But if I was to connect those two lines and I asked you, where is the middle, okay, instead of just guessing, hey, I think the middle is here, 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 you can actually calculate it, and the middle is at -3, -4, right here. That is our midpoint. Like I said, I didn't draw a great line, but you get the idea. So I'm going to erase this real quick because I want to demonstrate again on the next problem. The next one I'm going to do is example number 4. So example number 4 says to find the distance between C, sorry, I kept it on the eraser. Find the distance between C and F. And so it lets me know what C is. C is -1, 2. That's my X and my Y. F is 3, 5. That's my X and my Y. And so again, to start off with, I need my formula. So I've got distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Could have written that a little better. It's okay. And I need to decide which point is going to be number 1 and which point is going to be number 2. So again, I kind of do a scan and look at the numbers and see if the math is going to be any easier one way or the other. And since F has larger numbers and I'm doing subtraction, I'm going to go ahead and make F number 2 and C number 1. So when I have my formula, just like last time with the midpoint, I'm going to replace the variables with their values. So first thing I'm taking out is the 2's, the x2 and the y2. And I'm going to replace those with the values from the respective point. So I said F was point number 2. That means x2, x2 is 3 and y2 is 5. And remember, I'm doing subtraction right here. And I am taking away the point number 1 values. And so for point number 1, I have got x1 and y, sorry, I don't know why I put 2, y1. So I'm going to plug these numbers in. X1 is -1 and y1 is 2. So in my first parentheses right here, I've got 3 minus -1. And subtracting a negative number is just like adding that number. So I technically have 3 plus 1, which is 4. And don't forget, I'm going to be squaring that. Adding to that, I've got 5 minus 2, which is 3. And I'm also going to be squaring that. So 4 squared is 16. 3 squared is 9. And together, those are 25. And the square root of 25 is 5. And so the distance between these 2 points is 5 units. If you were to go up and plot that just really quickly, I dropped my pencil, sorry. If you were to go up and plot these points just really quickly, you would have point C at -1, +2, okay, that's C. And you would have F at 3, 5, right here. And so I'm trying to figure out what is the distance between them. All right, what is the distance between them? And according to the math that we just completed, there is 5 units of distance between those. So again, for example 2, example 3, you'll be using the midpoint formula as I did with number 1. And for example number 5, you'll be using the distance formula as I did with example number 4. So just make sure that you keep track of points 1 and 2. Whichever one you designate, keep it that way. And then make sure that you are staying organized as the problem gives you information and you are plugging that information into the formula. Other than that, follow your order of operations and good luck.